Alright guys, this is Unit 6 Lesson 4, and today we're going to be talking about exponential functions. So we've done a lot of work with linear functions, which we know has a constant rate of change. Last lesson we looked at some exponential growth and decay, and this lesson we're really going to have a formal way of writing exponential functions, so we'll see how that works. So we have our first function. It's exponential because the variable is an exponent. That's what makes an exponential function, is when the variable x is an actual exponent. So you guys should easily be able to hopefully find these different input values. So what is f of 2, f of 0, and f of negative 1? So go ahead and do those on your own. So hit pause and fill in those answers. All right, let's see how you did. So for 1i right here, did you end up with 232? Because notice it wants you to at what point. So remember, that is your input value, and here is your output value. So you should have got 32 because you put 2 in there. 2 squared is 4. 8 times 4, hopefully pretty easy. All right, for the double I here, you should have ended up with 8. And so again, you put 0 in there, and you know 2 to the 0 power is 1. And there we go. And they said this is also the y-intercept, because think about the x value is 0, and that means that you're on the y-axis when the x is 0. All right, third part, you should have ended up with 4. So again, you put negative 1 for your exponent. You should know that makes a fraction. We learned about that. So that makes 1 over 2, and therefore you're dividing by 2, and you ended up with 4. So hopefully you got those okay. That's basically input-output of exponential functions. All right, part B wants you to see if you could do this. It's going to be a little more difficult. Can you calculate the average rate of change, we've done this before, of f, the function from above, over this interval? So it gives you the input intervals, and you should be able to come up with a constant rate of change. So try that now if you can. Or average rate of change, I'm sorry, I shouldn't say constant. Okay, let's see what you should have gotten. Hopefully you got something like 4 over 1. So you could see f of 0 minus f of 1. Basically, that's when we take the difference of our ranges, or difference of our y's, rise over run, so y's over x's. So this was the output values when f was 0 and f was negative 1. So there's the difference of 4, and the input values, the difference of 0 and negative 1 is 1. So we had an average rate of change of 4. All right, part C, you're going to do the same thing, but look, they give you a different range. So see if you can do that now. Okay, what'd you come up with here?
Just a reminder.
All right, so with this one, again, you're going from the x value of 0 to 2. So when we put in 0 and we put in 2, we found the difference between those. So when you put in 2, it was 32. When you put in 0, it was 8. So the difference of that was 24. And the input value of 2 and the input value of 0, obviously the difference is 2. And then there you can see the average rate of change. All right, let's keep going with this. All right, what does comparing your answers from B to C explain about the function? So look at the answers B to C. Notice, bring those back up, is that you had an average rate of change of 4 and an average rate of change of 12. Do you know what that means? So if you do, go ahead and write something in for D. If you're not sure, I'll show you in a minute. All right. Did you notice that since the average rate of change is changing, it is not constant? Therefore, this should tell you, tell us that basically it's not linear. All linear functions have a constant average rate of change. So no matter what points we would look at, the rate of change should be the same throughout. This one, it's changing faster over different intervals from C and B. So therefore, it's not linear. Important to know. All right, moving on. Now we're going to see if we can use our calculator to draw this in. Now, I don't have the calculator function. What you should do, though, these are the windows they want you to set. Look, here's your y max, and that's your y minimum. So you should put that in the window range. Here's your x minimum and your x maximum. And what you're going to do is you're going to go back and put this function right here. Now remember, when we put it in our calculator, we hit the y for the y equals. The f of x is the y equals part. And then you would hit 8. You could even do parentheses or times 2. Then remember, you're going to use that little caret button. That's for exponent. And then you could put your variable in there. So you're going to enter something like this in the y equals part of your calculator. So hopefully that makes sense. If not, I could help you in class when I could show you in person. So go ahead and try that and see if you can come up with a graph for this function. So try that now, please. All right, hopefully your graph looks something like this. Okay, and you can see we have our x-intercept, which we said that point was when it was 0, 8. And this is what an exponential function looks like. It starts off kind of growing gradually smaller and smaller, but remember, it's like doubling each time. It's getting bigger, and it's going to start growing really fast, and it's going to, as the more you go, the faster it's going to grow. So when we say things are growing exponentially, it means each time it's growing faster and faster. Or if it's decaying, getting smaller exponentially, it's getting really small each time. So this is a perfect example of an exponential graph. You could tell it's not a linear graph because it's not a straight line. So this is an exponential function. You will have to know the difference between linear functions, exponential functions, quadratic functions. So make sure you understand that this is exponential. All right, so here is kind of a broad formula for the exponential functions. You definitely get to know this. Okay, so exponents means multiplying, so it's all about that. What we're going to do is going to be in this general form, like y equals mx plus b. This is its form. Y equals a b to the x power, where a is the y-intercept. Okay, so where you're starting from, your initial value, that's your a. B is the base multiplying factor. So if you were doubling something each time, that would be 2. So whatever you're multiplying by becomes the b. And obviously the x is going to stay in x because it's an exponential function, it's a variable. Okay? So b is known as the growth factor, sometimes the decay factor. All right, so let's try this, see if this works. So this should be kind of easy for us. So here is a function. This is function g, and it wants you to find g of 0. And then without using a calculator, could you find g1 and g2? So don't use a calculator for these. All right, so give that a try now. All right, how did you do with part A? Did you end up with something like this? So again, if we're going to find g of 0, we're inputting 0 into the x, which would be here. You know anything with a 0 power is 1, and 54 times 1. And we could write this as a point, because that's your input value or x value. That's your y value. So this must be the y-intercept. And notice we said it would be in the place of the a right there from this formula. We said that first a is your y-intercept. All right, bring this back up. All right, now could you find g of 1 and g of 2 on your own? So if you haven't done that, do it without a calculator. All right, how did you do? Okay, again, this shouldn't have been too difficult. We were just inputting 1, so 1/3 to the 1 power means 1/3. Basically, you're dividing by 3 and you get 18. Put in 2, so 1/3 squared would be 1/9. 1/3 times 1/3 is 1/9. Now you're dividing by 9 and you get 6. So you need to be able to do these here. Okay. All right, moving on. All right, so again, we're going to try to use our calculator. And look, it gives you a window. Here's your x minimums and maximums. Here is your range, minimum, maximum. So put those in, okay? And then, again, what you're going to put in your calculator is this here. So, again, I can help you just a little. You want to do something like 54. I would just use parentheses, really easy. You can do 1 divided by, which should bring up this, 3. Close the parentheses. Use the caret button for exponent, and then put your variable in. So that's what you could enter when it says y equals. You can put that in, just like that. All right, and try that now. And you should have came up with something like that. Okay, so notice what's going on with this one here. Okay. So if you do look at D, it says, why is this exponential function always decreasing? See, it's going down the whole time, it's still getting smaller. While exercise number 1 is always increasing. So what was the difference between exercise 2 and 1? Why is 1 increasing and 2 decreasing? Do you think you could fill something in there and explain why? Well, what we're looking for is something like this. This exponential function is always decreasing because we are multiplying by a number less than 1. Okay? This one we were multiplying, remember, by 1/3. If you think about it, if we keep multiplying by a third, it's going to make things smaller. Taking a third, taking a third, taking a third, that's going to be smaller. The first one, we were, if I could go back to it, sorry, we were multiplying by 2 each time. So it was getting bigger each time because we were multiplying by 2, and that's why it was increasing. So that's kind of why you could tell that they're increasing or decreasing just by looking at them. So, I'm like, oh, I don't want this stuff. Let's get rid of that. I don't know why that's there. There we go. Now, so this right here we would fill in something like this. So we know that we'll have a exponential function will always increase if your b, the multiplying factor, is greater than 1. If your multiplying factor is less than 1 but greater than 0, so not negative, but in between 0 and 1, like a fraction, like 1/2, then we know it's decreasing. So this is very important for you to understand, okay? All right, let's move on to exercise number 3. For this one, all they're asking you to find is give its y-intercept and tell whether it's increasing or decreasing for each of these functions. So again, what is the y-intercept? And is it increasing or decreasing? So please try all 3 of those now. Okay, how'd you do? So for part A, hopefully you said the intercept was 8, and it's decreasing because remember this is the A, so 8 is the intercept, and this is less than 1, so therefore that is a decreasing exponential function. For question B, you should have said the intercept was 125, and 1.5, that's your B, is bigger than 1, so that is an increasing exponential function. And finally, for part C, you should have said the y-intercept is 56, and 3/2 is greater than 1, so that is also increasing. So it's good to be able to identify these fairly quickly. All right, moving on. For this one, the equations of exponential functions are relatively easy to determine if you understand this lesson so far. So let's see what we could do. So find the equation of the exponential function. So we want you to write something in this form: initial value, y-intercept, the increasing b amount, okay, for this table here. So they're giving you the table. You should be able to come up with an equation and then explain or show how you got that. So hit pause and give that a try now. All right, how did you do? Did you realize that this is the y-intercept right there? Think about the coordinate grid. When x is 0, that's when you're on the y-axis, so the point 0, 10 is the y-intercept. And then did you figure out what is happening to each of these? Hopefully you see you're just multiplying by 3 each time. So that's your multiplying factor, your b. So with that information, you should easily be able to write a function like this. So b again is your y-intercept, your initial value. 3 is what you're multiplying by, and this depends on which one we're doing. And you can kind of read how that works right there. So if you're able to write this successfully, then you'll do fine in the lesson. If not, you definitely need to get some help when we do the fluency. And we'll see you in class.